This week we're going to be talking about our solar system. Our solar system is defined as the Sun and all objects that orbit it under its gravitational influence. This includes asteroids, which are large space rocks, meteoroids, which are small space rocks, planets, which are spherical objects that orbit around a star, moons, which are objects that orbit around a planet, and comets, which are objects that orbit around a star that are made of ice. Most of our solar system is empty space, and it's important to remember. Of the matter that's in our solar system, 99% of it is the Sun, which means that all the other objects are 1%, and that includes planets, asteroids, meteoroids, and comets, and moons, and anything else that happens to be floating out there. The solar system formed from a nebula, which is a cloud of dust and gases, and it's probably the remains of an exploded star. And the nebula is contained mostly hydrogen, but it does have some heavier elements. The nebula is going to start moving, and it's probably going to start moving because of a shock wave from another exploding star nearby. And once it starts to move, it's going to spin, and dust particles are going to start colliding with one another, and gravity causes them to stick together. And it's no different than forming a snowball. Bit by bit, chunks stick together, and as they grow and grow and grow, we get all the objects in our solar system, including the Sun, planets, moons, asteroids, and comets. We can see in this diagram here that we have the nebula first, and then the Sun is starting to condense into what we call a protostar, with that cloud of other matter swirling around it. And as time goes on, it becomes more defined, and the objects become bigger and bigger as they're swirling around the Sun, until finally we have the solar system that we're most familiar with large planets orbiting the Sun. It's important to remember, though, that collisions still happen. We've had meteorites collide into the Earth very recently, and other parts of the solar system this is happening too. So the solar system is still forming. One of the things we need to understand this week is gravity. Gravity is one of the four fundamental forces in the universe, and we don't know exactly why things have gravity, but we know how gravity behaves. And the basic rule for gravity is that matter attracts matter. And the bigger the matter is, the stronger the gravity is, and the closer two objects are together, the stronger the force of gravity between them. And that's really the essence of what gravity is. Because of the way our solar system formed, there's a few trends that are important to notice. The first is that everything in our solar system at first was spinning in the same direction on roughly the same orbital plane. And you can see in this diagram, the distances here are very wrong, but the basic shape of our solar system is right, where everything is in roughly the same plane of orbit. The second thing is that the planets that are close to the Sun form denser rocky materials, and the planets that are further away from the Sun formed from less dense gaseous materials. And the planets that are closer we call terrestrial, and they tend to be much smaller, rocky, high density. They often have craters. They have no rings, and they have actually most of them don't have moons, except Earth has one and Mars has two, and they're close to the Sun. Jovian planets are the further ones away, and they are very, very big. They're made of gas. They are very low density. They have no solid surfaces. They have many, many moons. Some of them have rings. Saturn is the most defined rings, and they're far away from the Sun. And it's important to remember that of these basic trends, a lot of things have changed. Big collisions in space have caused some of the planets to sort of change their orbit. They've caused some of the planets to tilt on their axis, but the basics are still true, where they're all going in the same general direction around the sun, and most objects spin in the same general direction, which we tend to think of as counterclockwise.